transfer from one body to another of different temperatures happens around us all the time. Our naked eyes may not see its process, but we can see its effects. We even depend on these effects. The heat we get from the sun, air conditioning, and cooking of food are just some processes or activities that involve heat transfer. Hence, heat transfer is essential in our daily lives. You have learned in the previous grade that heat transfers from one body to another of different temperatures through conduction, convection, and radiation. Heat always moves from a body of higher temperature to a lower temperature. Moreover, the conductivity of materials and temperature differences are some factors that affect the rate of heat transfer. People think that heat and temperature are the same. However, in physics, although they are related, these terms are not the same. So in this module, you will learn the difference between heat and temperature. Also, you will learn more about heat transfer and the factors that affect the amount of heat an object can absorb or release. Below is a word search puzzle. Find the words related to heat and temperature listed below by encircling the words. The words may be written horizontally, vertically, or diagonally. Have you ever experienced having a fever? You usually touch your forehead or neck to check if you have a fever or not. You use your sense of touch to tell whether an object is hot or cold, or one is hotter or colder than the other. When bathing a baby, you dip your fingers in the water, and when you prepare baby's milk, you sprinkle a few drops of milk on your wrist to check if the temperature is just right. When you are about to fry some food, you sprinkle some water to see if the frying pan is already hot. When you feel you are warm, you often say you have a high temperature. When an object is cold, you often say it has a low temperature. Temperature is commonly associated with coldness or hotness of a body. How do we quantify this difference in the hotness or coldness of a body? You might have experienced that your mother checked your temperature by putting a small glass tube called a thermometer in your underarm. Look at the data obtained in an experiment where 200 ml of pure water is heated and boiled. Observe what happens to the temperature as the water is being heated. What happens to the temperature of water as time elapses? The answer is, as time passes, the temperature of the water increases. What is the temperature when the water boils? The temperature of the water as it begins to boil is 100 degrees Celsius. What happens to the temperature of water while it is boiling? The temperature of water while it is boiling remains the same. What happens to the temperature of the water when heated? In the activity, as time elapses, the temperature of the water increases. The temperature of the water as it begins to boil is 100 degrees Celsius and remains the same while it is boiling. Temperature is a measure of hotness or coldness of an object. Kinetic molecular theory tells us that all matter has molecules or atoms which are constantly moving, thus, they have kinetic energy. Molecules are constantly moving but at different speeds and in the same direction. Moreover, the faster these molecules move, the more kinetic energy they have. The more kinetic energy, the higher is the temperature of an object. Temperature is a measure of the average kinetic energy of molecules. When molecules move faster, they have a higher temperatures, while when molecules move slower, they have lower temperatures. How do you determine the temperature of an object? Can you use your senses to determine the temperature? Try this simple activity as illustrated below. Set up 3 glasses of water, glass A with lukewarm water or maligamgam na tubig, glass B with cold water, and glass C with tap water. Dip your left forefinger in glass A while the right forefinger in glass B for 40 seconds. Then quickly dip both of your forefingers in glass C. What did you feel? This shows that our senses give us an inaccurate measure of hotness or coldness of an object, making them not reliable indicators of temperature. Thus, we need a thermometer to measure temperature. A thermometer is a sealed glass tube containing mercury and with an imprinted temperature scale. The mercury expands or contracts, causing it to move up or down when there are changes in the temperature. What is heat? When a barbecue has just been removed from the fire, you know it is hot and may burn your tongue, so you do not bite it immediately. Caloric theory, an early theory on heat, considered heat to consist of a fluid called caloric fluid, which flows from hotter objects to colder objects. James Prescott supersedes this theory by providing that a measurable amount of mechanical energy can always be transformed into definite amounts of heat. He called this quantity as a mechanical equivalent of heat and has a value of 4.186 joules equivalent to 1 calorie. He also concluded that heat is another form of energy. Heat is produced from molecules of matter that continuously vibrate. Heat is an energy form that transfers from a body of higher temperature to another body of lower temperature. Once heat is transferred or released, it affects the internal energy of the body. Internal energy is the total energy in a body, thus, it includes the potential energy and the kinetic energy of the molecules or atoms in an object. Joules is the international standard unit of heat. Another common unit of heat is calorie, defined as the amount of heat needed to change the temperature of 1 gram of water by 1 degree Celsius at a pressure of 1 atm. To avoid confusion, calorie is not used to refer to an amount of heat. It is used by dietitians or nutritionists to specify energy content of food. The 3 common temperature scales are Celsius, Fahrenheit, and Kelvin. Anders Celsius introduced the Celsius scale in 1741, while Daniel Gabriel Fahrenheit introduced the Fahrenheit scale in 1724. Both scales used the freezing and boiling points of water as reference points. On the Celsius scale, the freezing point of water is 0 degrees Celsius, while its boiling point is 100 degrees Celsius under a pressure of 1 atm, having 100 intervals between 2 reference points. On the Fahrenheit scale, the freezing point of water is 32 degrees Fahrenheit, while its boiling point is 212 Fahrenheit, having 180 intervals between 2 reference points. The difference between these 2 reference points is divided equally into intervals called degrees. William Thomson, also known as Lord Kelvin, introduced the 3rd temperature scale, which is called Kelvin. This scale is based on absolute zero corresponding to 0 Kelvin. It is the lowest possible temperature, and it is when the molecules of the substance have the lowest energy. Kelvin scale cannot have negative temperatures. On the Kelvin scale, the freezing point of water is 273 Kelvin, while its boiling point is 373 Kelvin. The temperature difference is 100 Kelvin. The difference in temperature between 2 reference points in the Celsius scale is also 100 degrees Celsius. So, when comparing Kelvin and Celsius scales in terms of change or difference in temperature, 1 Kelvin is equivalent to 1 degree Celsius. The symbols degrees Celsius, degrees Fahrenheit, and Kelvin are used to report temperatures of objects, while Celsius, degrees Fahrenheit, degrees, and Kelvin are used for temperature difference or change in temperature. For example, the freezing point of water in the three scales is 0 degrees Celsius, 32 degrees Fahrenheit, and 273 Kelvin, and its boiling point is 100 degrees Celsius, 212 degrees Fahrenheit, and 373 Kelvin respectively. Hence, the temperature of the water from freezing to its boiling increased by 100 Celsius degrees, 180 Fahrenheit degrees, and 100 Kelvin. Thus, 100 Celsius degrees is equal to 180 Fahrenheit degrees and also equal to 100 Kelvin. The relation between temperature in Celsius scale, temperature in Fahrenheit scale, and temperature in Kelvin are as follows. What is the normal human body temperature? 37 degrees Celsius in the Fahrenheit scale. In the Kelvin scale, when the temperature of substances changes, its molecular structure and movement also change, which results to phase change. Fusion or melting is the process that causes a solid to change to its liquid state. The amount of heat required to produce this change is called heat of fusion. When liquids release heat, the water molecules begin to move at a slower pace. The space between the molecules become compact. The process of changing liquids to solids is called solidification or freezing. When water boils, evaporation takes place. Heat is absorbed and water is converted into steam or water vapor. The amount of heat needed for a liquid to evaporate depends on the boiling point of the liquid. When water vapor releases heat, its gas state changes to the liquid state through condensation, which accounts for the formation of clouds in the water cycle. In addition, sublimation is the process of transforming a substance from the solid phase directly to the gas state without passing the liquid phase and requires additional energy. On the other hand, deposition is the process of transforming a substance from gas to solid without passing the liquid phase and requires a release of energy. During any of these phase changes, energy is either given off or taken in. When a substance changes phase, the temperature does not change, and only the amount of energy changes. Have you experienced when a metal lid cover of a bottle or glass container gets stuck? What do you usually do? Yes, you heat it or you pour hot water over the metal lid to open the bottle or glass container. The hot water or high temperature causes the metal lid cover to expand. What do you usually do when drinking glasses stick to each other? The safe way of separating them is by pouring cold water in the inner glass and dip the outer glass in hot water. Why? This is because substances expand when heated and contract when cold, making it easier for the two glasses to be pulled apart. The amount of expansion and contraction depends on the kind of material and cannot be seen by the naked eye. If 5 blocks of different metals, aluminum, iron, copper, gold, and lead, of mass 100 grams, having the same cross-sectional area and same initial temperature before being placed into a block of ice. Gold melts the most ice and sinks the deepest. Second is aluminum, third is iron, fourth is copper, and lead is the last. This only shows that although these metals have the same mass and initial temperature, they absorbed and gave off different amounts of heat. This is because these metals have different heat capacities. The heat capacity of a body is the quantity of heat necessary to raise its temperature by 1 degree Celsius. Substances with high heat capacities cool down slowly because they have to give off more heat and also heat up slowly because they have to absorb more heat. Substances with a low heat capacity heat up quickly and they lose their heat quickly. For example, you're stirring a pot of soup on a stove using a metal spoon. If you leave the spoon on the pot, the spoon will be hot enough and may burn your hand while the soup will feel warm. This is because the metal spoon has a lower heat capacity than the soup. The specific heat is the amount of heat necessary to raise the temperature of 1 gram of a substance by 1 degree Celsius. The table below shows the specific heat of some common substances. Complete each statement using a term or terms from the list below. Write true if the statement is correct and false if the statement is wrong. Study the figure below that shows thermometers in different temperature scales. Complete the table below. Use the figure to determine whether each statement is correct or not. Given the setup below, answer the questions that follow. Read and analyze each item carefully. Tell whether the situation applies the concept of thermal expansion. Write yes if it does, otherwise no. Write true if the statement is correct and false if the statement is wrong. Complete the crossword puzzle below. Write true if the statement is correct, false if the statement is wrong. Choose the letter of the correct answer.